Now the recording has started. Sorry for interrupting.
All right, that's fine. Okay, so once again, I want to welcome every one of us to this closing live session, and we'll be wrapping up the introduction to bioinformatics workshop today with this live section. We would be discussing about a critical topic and going also into a hands-on session during today's live section. And ultimately also we'll be speaking to us about the next phases of these ongoing 4 months research mentoring program in bioinformatics. So as you may be aware, my name is Adekunle Adelwoye. I'm the program director for Omicslogic Africa and UREKA, and also I double as a faculty with Lee City University. And I remember last week we tried to, earlier this week, during the opening section, we tried to explain to us about the big data challenge we have today and the opportunities they also present. And we explained to us the phenomenal growth in adoption of high throughput technologies, such as the next generation sequencing, and how today these are being applied into research, into biotechnology, into clinical practice. One typical example, a case in scenario is, what many of us can connect with back in 2020 when we had a pandemic. We were very much aware of how, the speed at which the scientific community was able to come up with a vaccine, despite several fronts and several ups and downs around the use or acceptability of such vaccines. But you will agree with me, before now, to bring to the marketplace a drug or a potential vaccine will take years of research and work before we get to that stage. But apparently, leveraging on the advantages of high throughput technologies and what the advancements we have in molecular science as a whole, we were able to do that at a record pace. And a big thanks goes to bioinformatics and a whole lot of tools that are available for such speedy research and output. So these are part of the big data challenges, as well as the opportunities that comes with them. Of course, on the flip side of every challenge is an opportunity. So, and that is what led us into the discussion we have been on, which is bioinformatics, introducing, the scientific community, the academic community, the industry participants to bioinformatics and how they can use it to up their game, scale up their research and, activities. And so we came up with the 4 months bioinformatics learning research mentoring program, which is phased. And the phase 1, which is the introduction to bioinformatics, course, started Monday this week, 22nd of April. And of course, during that section, we made it clear that the online coursework for the introduction to bioinformatics will be spanning the space of 5 days. And I'm happy that many of us had taken advantage of the lessons and courses we made available up until this very moment. And also, today, we're here to share some of the links for today's lesson, but we'll be doing that shortly. It's something I know many of us will be able to complete without delay. But importantly, we would be going into today's section to talk about something critical, something novel, which is also another part of bioinformatics. And so last session, we essentially talked about the expanding research project Horizon with Bioinformatics and looked critically into the presenting your data session. Okay, so of course, as a form of quick review, I remember during that section we were, basically told, what bioinformatics is, how there is an intercept, between biology and data set, and how these can be explored, to provide us informations that are usable, that can be translated into science, and also translated into different aspects of human lives. We were told about citizen science, and we looked at simply leveraging these bioinformatics tools to explore data, and to to make visualize this data beyond just generating these data within our laboratory. And so in today's section, this closing section, we will also again be going into another practical section. We'll be going into a presentation by our faculty for today. The presentation is titled Network Science and Analysis in Multiomics. Okay, but in details, the focus of the session is to talk about network graph in bioinformatics, analysis, how it can be used in bioinformatics analysis. And then we intend to give participants some form of hands-on section, and then ultimately at the end of that that hands-on presentation section, we'll be looking at your next step in bioinformatics, where we'll be detailing the course, the phase 2 and 3 of this program, excuse me, that centers around the bioinformatics skill up courseworks. We have a number of tracks that we have prepared for participants to join in, and a whole lot of information will be going out from this moment after this live session on our platforms. And then ultimately, we move on from that also to the phase 3, where the mentoring phase will happen. So it is my pleasure this afternoon again to introduce our facilitator, Dr. Ayanfe, whom I will be, transferring this presentation over to hand over to handle that part, while we go through the network graph in bioinformatics analysis hands-on session, immediately without wasting time. Dr. Ayanfe, over to you. Hello? Dr. Ayanfe, can you hear me?
Yes, I can hear you. Sorry for that. I will be sharing my screen right now.
Okay.
Please do confirm when you can see my screen.
We're here to see your screen, please.
All right. Sorry, 1 minute, please. Please, can you see it? Please, can you see my screen now?
Yes, we can now.
And confirm if it is changing as
yes.
I just. All right.
Yes, it is.
All right. Hello, welcome one, welcome all. I want to welcome us again to this session. Today, I will be speaking on network science and analysis in multiomics. I'll try as much as possible to simplify it so that we can all follow, and such that beginner bioinformatician can also make sense of it. I'll try as much as possible to also make sure that complex concepts are also broken down so that we can follow through. I need to once again welcome us to this fascinating world of
be mindful of the time nonetheless. Thank you.
All right. I'm going to say that again. I'm going to welcome us again to this fascinating world of bioinformatics. Today we'll be diving into the magic of network graph, and I just want us to imagine these graphs as maps that show us how different elements in biology are connected, like a giant web of biological relationship. So get ready to explore this exciting field with me. That being said, I want us to picture network science as a special tool that helps us to understand the complex relationships in biology. It's like it have a superpower to unravel the mystery of how different elements are connected. So just like a treasure map, the way a treasure map guides us through uncharted territories, we have been able to see the potentials that network graph can actually provide. It has the ability to provide a visual roadmap to explore the relationship between nodes and edges. What are nodes and what are edges? That's the next question. In the world of bioinformatics, I want us to know that these graphs are like magic mirrors that actually help us to see or reflect hidden patterns and insight within the data. So by visualizing these networks, we can navigate through the vast landscape of biological interactions, shedding light on the mysteries of transcriptomics, metagenomics, and so on. All right. That being said, I need to speak to the fact that we being biologists, we understand the places of dogmas and foundations or bases. The same applies to this field. We have that has its own fundamentals of graph theories. And this fundamental actually helps us to understand connections between elements. It's like you're trying to draw lines between friends that knows each other. So let me speak complex now. So this graph will help us to, I mean, after we have drawn line between friends that knows each other, these lines will actually help us to navigate through the web of biological relationship. So, like you can see here, what constitutes a graph? A graph is actually made up of vertices and edges. Vertices like x-axis, y-axis, and edges. By edges, we're talking about points that connect even through in a graph, right? There are other concepts of graphs that speaks to adjacency and incidence. That's when we start to define the relationship that actually happens or that we can see in a graph. That notwithstanding, it's also worth speaking to the fact that there is a concept known as directed and undirected graph, like signposts in a vast network landscape. It guides us to to understand if a connection is one way or the connection is two ways. So this kind of connection between an element is also very, very important to also take note of. There is something known as weighted graphs. And this actually helps us to assign. So a graph is not a graph until we are able to assign a numeric values to edges. So this represents the strength or the importance of the relationship. So I think I'm speaking in a very, very interesting things that we actually know. It's also important to understand that there are algorithms that has been written to help to understand what is going on. And one of those algorithms comes under the name transversal algorithms. This actually helps us to navigate through complex data structures. And on the basis or on the strength of the graph theory, the backbone of network representation is built, which means that it is very, very mathematically acceptable. It means that It's been accepted even in the scientific community. By understanding the fundamentals of graphs, adjacency, incidents, we lay a foundation to interpreting the intricate relationship within network model. Now, let us talk about how we represent and model networks. In this work here, we can see a work done by Enwu, submitted by J. Wang, on learning effective road network representation with hierarchical graph neural networks. Like we're trying to create a blueprint to understand the structure and the dynamics of complex biological system. So by using models, these models, for example, we can actually uncover hidden patterns. That being said, it's important for us to understand that network representation and modeling are actually the key to unlock the secret of complex systems in bioinformatics. So graph theory serves as a powerful tool to capture the intricate relationship within network that actually enable us to get a deeper understanding of the network structure and the network dynamics. So effective techniques that requires us to employ adjacency matrices, adjacency lists, incidence matrices. They eventually or in the long run, they provide a virtual blueprint to analyze and visualize the topography, the topographical properties of a network. So as we delve, yes.
Please confirm if others can still see your screen. I think there was a network glitch, and at some point, okay, the screen is available, but then not as a presentation mode. I hope that is not peculiar to me.
Yes, it's not.
It's on
Okay,
presentation.
so please
It's
kindly
not in
stop.
presentation mode.
Yes, stop and represent, please.
Okay, let me do that now.
All right, yeah. So it's back. You can proceed, sir. Sorry, we cannot see the presentation screen again.
All right, let me do that so that thank you so much for calling my attention. I believe it is visible now.
Yes, it is.
Yeah, I think when I zoomed in, I probably might have stopped sharing. So I was speaking to the fact that network modeling is key and is actually pivoted by the graph theory, where the graph theory helps us to capture the intricate relationship between network so that we can understand structure and dynamics. Modeling with I mean using the right tools like adjacency matrices, adjacency lists, and incidence matrices actually help us to understand and provide visual blueprint. So all these visual things that we see in the networks are actually played by, are actually result of some of these technical words I used. So they help to provide visual blueprints so that we are able to understand, analyze the topographical properties of networks. So as we dive more into this, I want us to just relax, because there will still be some few technical more terms I'm going to mention, but in the end, it's going to pay out. It's going to really make sense. So let us continue as we tend to explore more. It's very, very important to understand that these tools, the graphs, network graphs are actually instrumental to uncover hidden patterns and insight that underline complex systems in genomics, transcriptomics, metagenomics, epigenomics, and so on. All right. So I would love to introduce us to network graph. Imagine network graph as just that mirror itself that helps us to reflect or to see genes, proteins, and other elements how they interact in biology. So when we start to study graphs of this nature, we can unlock the secret of how these elements are regulated, okay? So it's like having a backstage, pass to the inner workings of biological system. That's why it's actually been employed. That being said, the visual representation that a complex relationship within the system gives us is actually very, very important. And I know it seems as if I've been saying this thing in different ways, but the most important thing is for us to be able to identify groups of related elements, all right? So that we can actually gain insight into regulatory mechanisms, controlling expressions or activity, or some other drivers of biological processes. We need to also understand that there are some things that we need to look out for when we are trying to make sense or create hypotheses. Some of those things are the key players. By the way, another name in which we call the network graph is called the complex network. But let me come back. So some of the things we actually need to look out for are hidden patterns, key players, and dynamics of the system. Because once you have the network graph, it's very, very important for you to be able to start checking around, checking it, so that you can understand if there is something that you can unravel from the puzzle of connection that it will be shared with you. Why do we need this? So network graph, like a treasure map, like I mentioned, will guide us through the complex relationship in biology, to help us to visualize connection, identify important nodes, detect patterns, simulate how the system behaves. It's like having a secret code, really. So once we are able to detect patterns, motifs, let me say that again for those that were present yesterday. Once we are able to detect patterns, motifs within network structures, researchers can reveal underlying organizational principle, and they can look into, they can start to build hypotheses around functional models within the complex biological system. So it's like having a roadmap that we can navigate through the web. Although this web of biological interaction is intricate and not very straightforward, but that does not mean that we cannot uncover hidden insight. Application of network graphs in multi-omics field. I want us to know that it is not only used in the omics field, but let me just speak to it. So in genomics, network graph visualizes and analyzes gene-gene interactions and so on, regulatory pathways, complex genetic system, offering novel insight into genomics, genome organization and function. In transcriptomics, this graph model, it models gene co-expression patterns, so that we can identify key regulators gene, so that we can elucidate transcriptional regulatory networks, and so that we can also understand how this regulatory network, how they drive cellular processes, disease states in metagenomics. Yeah, it reveals not just complex ecological relationship, it also shows us keystone species, especially in a niche or in an ecosystem, so that we can understand interdependencies in each microbiomes. In epigenetics, I want us to know that I can continue so that we can understand that it is very, very important. But only 4 of these network graphs are actually mentioned here. In epigenomics, for example, the network representation, it helps us to understand epigenetic modifications, to uncover regulatory mechanisms, and chromatin organization. I mean, in short, it provides us deeper understanding of gene regulation. So by visualizing and analyzing network graphs, researchers can unlock the mysteries of biological systems and drive groundbreaking discoveries in multiomics research. That being spoken of, I want to just still take it a little further, talk about some other aspect that it seems like I left out. And although I mentioned about transcriptomics, about metagenomics, that it helps us to map out the community interactions, unveiling the intricate relationships between different microorganisms. It's like having a secret code to actually decipher the mysteries of biological interactions. I want us to also know that in proteomics, metabolomics, of course, it also plays a big role in illustrating protein-protein interactions, facilitating a lot of drug discovery insight and understanding other complexities. That being said, it is important to understand that there is something known as, or a concept known as, coexistent networks. And this coexistent network, as the name implies, means that networks that actually crosses and they coexist together, which is actually the beauty of the word multiomics. So when we are able to plot network graphs, for example, by constructing these networks, researchers can actually identify critical nodes. Please take note of the word nodes again and edges, because we are going to be having a practical, so that we can actually uncover the intricate web of interactions or interrelationships between different components, okay? That being said, what are the suggested coexistent networks in multiomics genes fields? I would love to speak, to bring this concept to life by using the example of the One Health. What does One Health underline? It's actually based on the coexistent, the understanding of the coexistent network relevance. So it means that, okay, if a bacteria becomes resistant to antibiotics, and this bacteria is peculiar to fish, and fish consumes, and this bacteria is relevant to the water body where fish production takes place. For example, I'm just citing an example. And this bacteria is peculiar to a particular species, fish. And even through the whole processes, people handling these fishes got to eat it. Now, the genes that is responsible for antibacterial resistance in that bacteria, for example, imagine how the system transfers, how the resistance gene is being transferred, and in the long run, there is an antigenic shift that happens even when man also consumes the bacteria in the long run. Coexistent networks. Just trying to paint a picture so that we can actually get it. So just imagine a gene co-expression network, just as a map of gene interactions, revealing groups of co-expressed genes are involved in related biological processes. So similarly, in metabolites, co-occurrence network unveils potentially related metabolic pathways and interactions. And these networks are like keys that unlock the secrets of biological systems. We have tools and algorithms. And these tools and algorithms, they're like, this magic wand that we use to create and analyze network graphs in specific area of omics research, which actually means that we use different tools for different aspects of omics research. These tools actually provide us like superpowers so that we can analyze, be it gene regulation, regulatory network, metabolic network, protein-protein interactions, and more. So by using these tools, we can actually unravel the mysteries in the biological systems. Now, let me come closer so that we can actually start speaking, so that we can understand what we actually have, so that we can see an example of some important concept. Because on the concept of these parameters, then can you build your network? Let's explore some common network parameters. We have an average path length that reflects the average distance between nodes in a network, showing the degree of separation. We have clustering coefficient that measures the relationship between nodes, while betweenness indicates the importance of nodes in information transmission. Connectance reflects the overall complexity and density of connection in the network. So exploring common network parameters is essential for gaining insight for network structures. Let me say that again. So why do you need to know this? Why do you need to know this? If you are going to speak like a scientist, or you are going to try to interpret a network graph, these are important things you should speak to. So talk about the average path length you observed, talk about the clustering coefficient, talk about the betweenness, talk about the connectance, and then will you be able to speak to the network structure? So I believe that we were able to understand that that is actually very, very important to unravel intricate web interactions within a network. There are other parameters like degree distribution, average betweenness, average nearest neighbor degree. We also have the case of diameter, betweenness centralization, and so on. So to dive deeper into centrality measures in network analysis, there's something known as degree centrality. That actually measures the importance of a node based on its connection, while betweenness centrality identifies the node bridging between the types of the network, while closeness centrality actually speaks to how the node is close to each other. That being said, I believe it's high time for us to have a case study. All right. So let us explore a fascinating case of the co-occurrence network diagram in ecology. I believe this is one of the simplest way in which we can actually go around this so that we are able to understand what's actually going on. I'm going to be using a tool called Chipplot. Yeah, because that one is accessible online. We don't need to install it on our computer, and we will be able to. I mean, this is just actually available online, and we can actually do this. So imagine yourself being a detective. Imagine yourself having to understand your notes and create this your note. So the diagram, the diagram here actually helps. For example, we have classes. I want us to look at this very clear, carefully. Okay. Here we have some classes. I'm trying to see. Am I able to pull it? Please confirm if the video is playing. If the GIF is playing, I'm not too sure if it is playing. Anyway, I think what I'm going to do is just to try to explain a little. So here we are able to see the different classes. We can actually also see the isolated classes around. Then we can actually see some interconnected classes of microbes, and it's actually a very interesting graph because it allows ecologists to easily explore the complex relationship between different elements, which just is research data. That being said, it's important to also talk about the global sphere, what the concept of network analysis is. So in recent time, let me go a little political. In recent time, it has been argued that many of these companies, big companies, let's say Facebook, Twitter, Instagram, LinkedIn, and co., they have been able to use AI. Now, the word should not be AI, but the word should be network analysis. They have been able to use network analysis or clustering algorithm to be able to to be able to get people's interest. Then they target you. Let me say that again. So when they know that your own interest is listening to music and you're always finding music, or listening to carols, for example, they already understand your interest. Then they start to target you with things like that. In the long run, people become adaptive. So this network analysis is actually not a concept that actually started in omics science. It is known as a network science. So there's something known as community detection, which is like finding hidden group of closely connected nodes within a network. Okay, so that we can unveil the underlying modular structures. So of course, clustering algorithm helps us to uncover the community so that we understand, okay, how are they clustered, so that we can actually group nodes together based on their shared connectivity patterns. And it's like just uncovering hidden society within a vast network. So that being said, it's important to also mention that there is a concept, or there is an idea of how ideas are spread through social networks. How somebody comes around with a rumor and just start to share it. So in the long run, understanding information can actually help us to predict the reach and the impact of the content and so on. So there is a concept known as information diffusion, and that is the same way it actually works. So information diffusion, like we have in social networks, almost like the same that we actually have here. So this network effect, what I'm speaking about now, a network effect. This network effect actually plays a crucial role on how information progresses, and if we are able to analyze the cascade patterns, and we will be able to understand, we would be able to cascade, to to help to identify drivers for viral content. And that's the same thing in this context. So not just in the digital ecosystem, this network analysis can be very, very powerful, such that you are able to tell that, okay, in the nearest future, this is the number of genes that will actually go sour. Or in the nearest future, this is the number, there's a tendency that a particular class of microorganisms will dominate and others will actually die out, and so on. So some of these trends can actually be seen, and this network effect can actually be seen on the premise that connectivity and centrality plays. And after we have actually analyze the cascade patterns, researchers can actually pinpoint influential nodes that accelerate diffusion processes, that accelerate that, so that we can actually unveil drivers behind viral content or depreciation or apoptosis or any kind of movement that our graph may actually suggest. Some other fields that actually uses network field include the social network. We have met with our biological network, and we can actually see our transportation and infrastructure. They also use this network, and we have finance and economic systems. That being said, let me come back to microbial co-occurrence network. It actually helps us to understand the microbial interactions, to identify co-occurrence patterns, and to understand the implications in the microbial ecology. So what are we trying to say? That this network can actually unveil complex interactions between microbial species within the community. They can give you insight into ecological relationship. They can show you potential symbiotic or antagonistic dynamics. And, studying this network can actually help you to identify not just species, detect microbial successions that will happen in the nearest future. You are able to foresee it and to understand the factors shaping community assembly, stability, and death. So let me just touch on one or two these things so that we can go into practical, because it seems like it is getting much more interesting the more I speak. Sorry, before I continue, I want to ask, do we follow me to this point? I want to ask, do we follow me to this point? I want to ask, do we follow me to this point?
Yes, although I had some network issues, but I think I understood some parts.
All right. Peter, Jonathan, Amina.
Yeah. Sorry, can you hear me?
Yes, I can hear you.
Yeah, I'm following. Though it still seems a little bit abstract because we are yet to go to the real thing.
Answer. Okay. All right. Oludare, okay, I think Kadmil Ajete just said yes, is following. Oludare too said, Oludare, I hope you follow. All right, you can still, the section is being recorded, so you can go back and get to understand what is actually happened. Okay. That being said, why do you need to visualize? We have mentioned this over and over again. Now, the other part I don't think I've actually mentioned is for you to be able to really draw up a targeted intervention. Because when you are able to identify key players, understand eco dynamics, then will you be able to guide a targeted intervention for desired outcome, for example, so that you can have improved health, maybe productivity, maybe stability of the ecosystem, just a magic lens that helps you to be able to propose, to draw a good hypothesis that will actually make sense. That being said, how and where do you start from? You start from data preparation. So we have actually made some of these files faster, FASTQ file. Very, very important. You need to prepare your data. It's very, very important because I'm going to show us a prepared data. So it's very, very important for you to prepare your data so that you can construct a microbial co-occurrence network. And your data must be high quality data with abundance of, in this context, with abundance of microbial taxa, so that you can lay foundation for understanding the intricate relationship between the microbial community. You must be very, very careful when you collect a sample, when you store, when you process them, when you decide to sequence them. Your protocols must actually be on point because you are setting a stage for a ground exploration into the microbial world. So what do? Then you start to look at how you can calculate your co-occurrence matrices across samples. You can measure with Pearson correlation, Spearman rank correlation. You can measure with mutual information mutual information, so that you can quantify the strength of association between microorganisms. You can do significant testing too. That one will actually help you to assess the statistical relevance of these co-occurrence values. So we're actually going from simple to complex here. This is actually something that has actually been explained. So how do you now construct your graph? Now, the details of how to construct graph here start from pre-processing, then your correlation calculation, then your network construction, so that you can actually make sense of this. So it's like you are trying to just create a visual map of microbial interactions, and that is very, very important. Let us look at the visualization. And there are actually a lot of tools that you can actually use to visualize your network graph. There are actually a lot of tools that actually serves, like the cytoscape, for example. It allows us to plot nodes representing microbial taxa. Okay. We can also see edges, so that we can actually. So let me say that again. Yeah, because I need us to understand this for the next thing that we are going to do, the practical. So when we talk about nodes, we're talking about microbial taxa, and when we talk about edges, we're talking about linkages that actually exist between them. So you are just trying to paint a picture of a web. So when you want to interpret the network, you need to identify the hub. That's to detect highly connected nodes. You need to detect also the clusters. Then you need to also analyze the connectivity. So also pay attention to the key taxa, the interactions, the hubs, and the keystone species. Very, very important. How do we apply this for future directions? Like I mentioned, it helps you to be able to prefer needed solutions in the right environment. That being said, what is the challenge, limitation of this network? Your ability to access data, your ability to understand the complexity, your ability to use it to increase your work, in the sense of your ability to use this data to create either a complex, a nonlinear, a dynamic, depending on the kind of model you are going to use, right? So you will not be using your traditional model to say directly proportional, inversely proportional. Now you are using serious dynamic words, okay? And your ability to also interpret, okay? That being said, what are the takeaways so far? You need to visualize. You need to learn to visualize network graph. You need to learn to interpret network graph. And you also need to understand the challenges that it has. We also need to understand that there is a future trend for this. Why do we need to do this? And are you permitted to be able to draw a network graph? Yes. But will it be easy for you to be able to construct your data, your purified data? No. Will you need tips? Yes. So there would be a need for you to have to engage an interdisciplinary collaborations. Confirm if the persons are able to do this. If not, that's one. Number two, if you're dealing with a big data, for example, you need to also understand that computational power is very, very important when you are trying to do a network analysis. Also, adaptive networks are actually very, very important because you need to understand the kind of models that you will be using, and in the future, it will be made easy. It's very, very important to understand that there's something known as a network bias. So ethical consideration is also something that we need to also look at, so that we can actually advance in every of this field. That being said, I would conclude so that I can go and show us the practical in 10 minutes, and that will be all. I'm going to call on the program director to take over. So in conclusion, I'm going to say that network science and analysis that actually offer us a fascinating journey into understanding complex systems and their interactions. By visualizing and interpreting network graphs, we can unlock hidden patterns and insight in various fields. When we overcome challenges in data availability, complexity, scalability, and interpretation, we'll be able to harness the full potential of network analysis. So I want to encourage us to embrace the emerging trend and opportunity in network science, interdisciplinary collaboration, computational advancement, and ethical consideration, so that we can shape the future landmark of not just the network research and for the development of research in Africa, so that we can pave ways for innovative applications and transformative discovery. I will stop sharing this slide at this point so that I can share my full screen. Okay. All right. Let me see if I'm able to share my full screen. Okay. Stop presenting. Okay. So I will share my full screen, my entire screen, so that we can actually see what's actually going on. Please do confirm if you can still see my screen. Please, can you still see my screen?
Yes, sir.
All right. So I'm coming straight away to this place so that I can show you a edge table that's Excel table and a node table, so that we can look at the uniqueness of how a typical node table looks like and a typical edge table look like. Now, this is the edge table. I'm not too sure. Can you see my screen?
Yes.
So we can see that there is a column that actually establishes the link. There is another column known as the source, and there is another column known as the target. All right. Now this is the edge table. Let me show us the node table. This is the node table. You have the ID, which differs from the ID of previously, and we also have a vague label. Okay. So let's go to the practical. Please, can you still see my screen?
Yes, sir.
Okay.
Yes.
I'm going to bring this back, reset this page. Please take note of the link, typlot.online/network plot. I think I'm going to share it in the chat in a bit. Okay. So I want to upload my data so that I can start to create something interesting. So I'll come here and I'm going to press this. I'm going to press this plus. So since I have my node, wait, that's not where I should start from. I should first of all come to my data here and select both of the files, okay? So let me come here and first of all upload the two files, file 1, file 2. So I've uploaded file 1 and file 2. Now note, all those words that we're talking about, are you seeing the way I'm dragging this thing? Please, can you see the way I'm dragging this thing?
Yes, sir.
Yes.
All right. We can actually see that when I selected node, I can change it if I want it to be plus or circle, but let us leave it as circle. We have a field for heat, and we can actually see these things. But what are even these nodes? These nodes, what are even these nodes? I also press the links. How do I want my link to look like? Should it look like a line? Do I want it to be arc? That one also depends on you, right? Our data, we have seen it, but now we want to layer it. We want to be able to make sure that we make sense of it. So that one will bring us to this aspect of the screen. Sorry. Yeah, that one will bring us to this aspect of the screen so that we are able to so that I can actually add a layer to it. So let me add a layer here. And then I'm going to add this layer here. Am I interested in the source? Yes. Do I want to color the source? Yes. I want to color the source. Yes. So let me add this. So here we can see different sources. And the question is, a legend has actually been created, but I'm not seeing what is color blue, what is color green. It seems like I did not select the right node to represent my data. You have to come back here. You will have to come back here and delete this so that you can select the right layer. We're going to come here again and select the right layer. What do I actually want to see? Is there a target? Am I interested in the links? Let us see. Yeah, I'm just dragging this thing so that I can zoom in so that we can see the links. So we can see that the links started getting different colors. Okay, based on the target. Of course, you can come and start to, let me select this. You can come to the legend and start to edit the legend. You want to change the name from target to another name. You can call it mileage if you want. Here is very, very possible. You can increase the font. You can come down here. Okay, target is very, very close to this thing, but you want it to be a little further. Let's just call it 20. That is downward. Let me call it minus 30. Okay. Yeah. Then I want target to be on the left here. So let me call it minus 22, minus 40. Are we seeing how target is moving to the left, right? So you can actually adjust these legends based on what you want to do, okay? Yeah, you can still come back to your layer of your, of what you actually have here. But the question is, what are these things that are here? So we can actually see there's a link from one OTU to another OTU. How about this node? I'm actually interested in the node. Okay, so I'm going to I can decide to leave it. I can decide not to leave it. But let me try to upload a node. Because I'm not interested in the links. Sorry, in the linkages. I'm interested in the node so that I understand what we actually have here. So let me come here. I need to add it to the layer. Sorry. To add this node sample to the layer, I'll have to select the node here. Sorry, this this box, and then will I be able to select the label? From the label, I want to be able to differentiate between the nodes. So I'm going to select color categories of nodes, not, I just want the color of the nodes to actually change so that I will understand that all of these nodes, they are not the same, okay? Now we can actually see the difference in these nodes. We can see that there are actually a number of nodes here. Yeah. And actually this labeling correspond, if you remember initially, this label corresponds to what? To different OTUs. Can we see this? These labels actually correspond to different OTUs. So from what we actually see here, it means that you should be able to look at this thing very, very well. To look at your data very, very well, prepare a data. I'm going to share this sample data with you. And you will be able to look at the distance, for example. Now, even though I'm dragging it around, of course, we can come here to adjust some particular settings. Not about the layer now. Talking about the main settings here. Let us come to the to the node. I want the name of the OTUs to actually show here. Yes, can we see the names of the OTU? I'm not interested. Let it be. Let me unselect, sorry, hide this. Okay. I think what I need to do is that I need to go off the legend so that we can just only look at this. Okay. And from here, I can start to work on the node. Okay. So what other options do I have in tweaking this node? I know that I'm not interested in the text. I don't want the text to show, but sometimes you may want it to show so that people can actually see it, okay? Some other things you can actually do is to size the connection. Look at this. So I just selected this so that there is a reverse roll. So there are actually some nodes that were bigger. They were bigger before. And there are actually some nodes that are now smaller because I reversed it. Look at this. So the bigger ones became smaller. And if I would just want all of the nodes to be the same size, kind of, look at it. Okay, so that's that. There's also a possibility to also do something with the force. If I change this force to 100 and let me say 120, minus 120. Let me explain what just happened now. It means that when I'm drawing this thing, when I'm trying to draw this thing, it will go back easily. And it actually has this tensile nature. All right. But let me take it back to minus 80, okay? Now, we had some particular parameters. We were hearing, I mean, we were exposed to some particular parameters name. I know some of us will remember those parameters, some centralities. And I remember that I also spoke to some particular algorithms, some particular these things. So let me mention here. I think I need to still go back there so that we can actually do the calculations. But here you are able to export your picture. If you want the legend to show, you select on the node. You come to the legend, you turn the legend on. You can do anything you want with this legend. You can play with it. You can change the layout. You can do anything. You can change the symbol. If you don't like the symbol, you want it to be monotonic. There's also another aspect I think we need to also look at. I think it is okay. We have gone the data. We've checked this. We have checked this. We have checked this. We've actually explored this. All right. So let me just come back here so that I can round up to talk about the link. So over here, I selected so that the link was actually available and I could do some one or two things with the link. So there are actually very, very little things to actually tweak concerning the link. The link, the legend, and so on. So the more quality your prepared datas are, I think we can actually give this data out so that you can actually look at it. The more quality your prepared data is, the more easy is it to plot a network graph. Next question, I think that we are the next aspect I think that we're going to handle in the long run is how do you create a node table from your OTUs or for your gene expression, and how do you create a hedge table and you are able to create the link between them. All right, so it's actually very, very possible to do that. On this note, will actually run up and tell you that this tool, now I turned on the boat. I turned the boat on, and here we are able to see some very, very colorful display. If I'm not interested in the legends, I can off the legends for the two. Okay, I think for this one too, is the legend on. Let me see it. The legend is also on. Let me off it. Now I've been able to establish draw a normal network graph. Now, that being said, if you really want to understand what is standing up here, you understand, right? Your legend must actually describe, or let us say name, let us say the class and co. So because the reason why we actually have a very, very long, how will I say this now? We have a very, very long legend here. The reason why we actually had a very, very long legend is because this graph or this table has already, this table is actually for OTUs. OTUs are already species levels. Okay, so on the species levels, you should expect to see, to actually meet a lot of species, and like some have relationship, some does not have. You would be even surprised that, okay, if you are interested in let's say you're interested in hydrogen metabolic microorganisms, for example, that just 2 or 3, for example, only these ones that only have relationships may actually be the ones dominating or doing hydrogen metabolism, for example, or breakdown. So we can actually see a lot of network, like look at this network here, very crisp, right? And whereas we actually see some isolated networks, for you to be able to see the names of these guys, for example, you can come to the node and turn on the point text. So you can see that OTU31 is connected to OTU74. At this point, you'll be able to really make more sense. Yeah, you may not even need this legend at one point. So you can just go to your layer and turn off the legend, and still, you're able to see it, relationship. All right. Thank you so much for your time. I would love to call on Dr. Adekunle at this point to take over. Are you there, sir? Can you hear me?
Yes, very well. Thank you so much, Dr. Adekunle, for this, hands-on session. Like you stated earlier on, it is my hope that the data set would be dropping it on the WhatsApp group and Telegram group pages, as well as the URL to that online platform where individuals are expected to just go there and also play around with what we've seen done this afternoon. So thank you once again, Dr. Adekunle. I think it would be good to ask for 1 or 2 questions. Should we have any? Okay, and so that way we can move on quickly. So questions, please. Do we have any questions from those of us who are live online? Any question, please? Okay, I guess I will have to proceed, share my screen now. All right. So yes, once again, thank you, Dr. Adekunle. In the absence of any questions, since we are not seeing any coming in, but I can show every one of us by the time we go over this video once again, and equally lay our hands on this to do this, we get to understand better. Someone earlier on mentioned the abstractive nature of these, network graphing and all of that. It's perhaps because you do not, what we are talking about with respect to the OTUs, which is operational taxonomy units, is, still, we haven't gotten good grasp of that even in itself. Okay, perhaps these are the reasons why, it looks so abstractive. But then, by the time we move on, and we move possibly into metagenomics, where we sequence our various, archaebacteria, all the microorganisms in a typical sample environment, we get to understand more the details about this OTU and how to make sense out of them, and where or how important then such network graphing like this, comes to play, where we begin to see the relationship, okay, venture to see relationship between the specific bacteria, okay, which many of us know to be a causative agent for a specific disease condition, and some other bacteria in that environment, and a whole lot of that. So let me move on at this point. So like we all know, currently we are the 4 months bioinformatics learning, research, and mentoring program is underway, and today is the end of the phase 1, which is the the introductory bioinformatics phase. So quickly, I'd like us to remember that, of course, that phase was provided free. Sorry, can you see my screen?
Yes.
Okay. I hope my...
No, it's white. It's just white in my place here.
Okay.
Yeah, it's black.
Okay.
Okay, now.
Sorry for that. So, like we said, as we anticipate many of us joining the phase 2 and the phase 3, okay, essentially in the phase 2, we'll be taking on a lot of bioinformatics courses, which we term as the skill up section in a track format. I will share more about that shortly. There are some projects designed from start to the end, which has been converted to coursework, which you start also, person get to go through this project to serve as a form of the project-based learning we mentioned earlier on. You can get to understand what was done, how it was analyzed, and of course, the scientific backgrounds to them, ultimately for us to be able to get to, the stage at which we are able to make sense of them. Okay, permit me to turn my camera on while I continue with this presentation. All right. So I move on now. So for those of us who will be proceeding to that phase 2, definitely we will end those certificates. And like we mentioned earlier on, the end of workshop certificate is available. It is optional. However, if you consider it necessary, you can reach out to us. I think the links for the payments to end this certificate at at the cost of 5,000 or $5 is available. And from what we saw on the group page this morning, I saw one of our growth ambassadors acknowledging the fact that someone already even made the payment. Okay, so that's about that. So, but moving on, this program will continue even beyond the phase 2. And starting from next week, Monday, we'll begin to engage those participants who have indicated interest for the phase 2, so they can be able to. Sorry, I guess my hello. I guess I'm having some issues here, technical wise.
Yes, we can see your screen, yes.
Okay, so sorry about that. I was also having that glitch here. So it is our intention that all participants for whom this program is designed gets to, tag along with us, and we dive deeper into the bioinformatics session. Of course, we believe everyone who is on this call is already registered and they can access their own personal learning platform. For those who are not yet, who have not yet done that, please. Registering on Omicslogic platform is free of charge. No charges attached. And of course, there are free resources, we can begin to enjoy there. All right, so we encourage participants to join us. And as we mentioned earlier on, we encourage all our participants to also ensure they keep a completed profile page so that they can maximize the very best of the opportunity this program avails all participants. And like we said, our project or our educational objectives or resources are project-based learning, research grade tools, as well as, working together in a cohort or, mentor participant relationship to also ensure we use what we have learned to achieve something tangible. And like we said the last time, moving forward, these, the phase 2, the bioinformatics courses will be track-based. So I'd like to state here, we look forward to, we'll be presenting these various tracks to participants. We'll equally be sharing a form between now and tomorrow where we expect all participants to indicate their own track of interest. So perhaps we want to go into the genomics track or the, infectious disease track or metagenomics tracks or transcriptomics or what have you, or the machine learning. Okay, so we indicate which tracks we want to go into. We'll equally be sharing a form, or perhaps on that same form, we will be indicating what topic we like to work on. Project-wise. Oh, I want to look at bioinformatics, analysis of contraceptive, the effect of contraceptives on female, maybe hormone and all of that. I mean, just think of these topics. However it comes to your mind, put it there. Of course, we'll be refining this further as we move further down in the learning process as well as the mentoring process. So we expect participants to indicate their own tracks of interest so that we can provide them courses related to that aspect. They get to build their skills further in that aspect and then move towards the project eventually, which we have stated. So already, I think we saw most of these slides the last time: genomics tracks, the transcriptomics tracks, metagenomics, which actually related a lot. You can see on that page, on the second graphical illustration, there's something similar to the network graph Dr. Ayanfe presented to us just a while ago on the metagenomics screen here. So all of this will be looked into. And for those who likes the R coding, let me state that the lesson for today is on R coding. I'll call it R programming language, which is a visualization tool. We'll be dropping that link very soon. It's just, I think, a lesson or two. So
Sorry, we can't hear you. And we can't see your screen. Am I the only one that can't see screen?
No, same here.
All right, I believe that is going to join back very, very soon. Update of what has actually been done today, like Dr. Adekunle mentioned, has been shared to the group. So the network plot, the weighted node, and edges. Once the link is out, the session is recorded. I believe that we would be able to just share that so that you can just go back and try to run it. Then if you still need more practice, I can still share other data with you. That will be, I don't know. I think that one will even look much more interesting. Yeah. So a lot of these nodes, yeah, so that you can practice to plot something, and we are able to see that. All right. We want to encourage everyone to join the phase 2, which will be much more intensive. It's going to be relatively different from this because there is actually more things to actually learn. I got the message that Anna shared. Ratobi shared a message, and she needs a clarification on something, on a multiple sequence alignment 1. So I think since I've stopped sharing my screen now, this has to do with generating a cladiogram, but you're not able to paste in the query box. So I think, and you also shared where the error is coming from. A minimum of 2 sequences required. But seems like, how many sequences did you actually drop there? We needed 2 sequences, 3 sequences.
Yes, I uploaded the 3.
We needed the 3, and it seems as if it did not get it. So by uploading, you mean copy and pasting, right?
No, I took the documents directly from my system. Like I uploaded, not copy and paste. So I just highlighted the 3 documents at once.
Okay, because from what I actually see here, it says copy and paste these sequences. So you remembered how we opened the document yesterday. If it's possible, for you to copy and paste, I think it will be efficient. But I will try to also open it and do a screenshot of my own steps. But please share this to the chat group and tag me on or any other admin so that I will not forget about this. Okay, so it is actually good to see that you are dealing with the tasks. Yes.
Then sorry, sir, when you say copy and paste, does that mean that I'll copy it? Like I don't get, is it that I'll first copy the first one, we'll put the second one on that, put the third one on that, because I don't know if it's possible to copy and paste, then upload, copy paste then upload, because asking for, I don't know what you mean by copy and paste, sir.
Okay. So so kindly share the link to this. I think I should have the link. It should be a continuation of yesterday's tasks. Yes, it should be a continuation of yesterday's task. But kindly share the links to me. I mean the link of this particular task to me so that I can look at it and put you through with it. By putting you through means that, I mean, once you tag me in the group, I'm going to answer. Maybe not in the next 1 hour, but I'm going to answer and share a screenshot, not only of my result, but of the steps I actually took, so that you can also look at it and also come back with a result. Okay.
Thank you very much, sir.
All right. That being said, I think I will have to share to share my screen so that I can complete what Dr. Adekunle has actually started.
Sir, can you hear me, sir?
Yes, I can.
Okay, I don't know. Can I ask a question?
Please, yes.
The various lessons, after this first week, would they still be accessible from next week? Because I've been quite choked by other activities, so I'm not able to go through all the lessons each day. But as we speak, I think I'm still in either day one or day two. One of the I think in day two. I'm in day two lessons. So I don't know. Can I still access them within next week? Hello.
All right. So I thank you very much for asking that question. I was going to say that in your opinion, before I answer your question, I wanted to know your opinion. Do you think the task are complex or is it easy for you to follow? In your opinion, please share.
Yeah, the tasks are very straightforward to follow, but just that it's kind of it's big in that one has to combine it. Like I'm doing my PhD currently, so I have to combine a whole lot of things with following up on the bioinformatics course. So it's straightforward. It's easy, and really it's cool because I have this thing for bioinformatics. I love it, so it's been good following it. But just that the materials are voluminous, so I may not have the time to switch up the ones. So that's just it.
All right. So I would recommend joint work for some particular instances. Why did I say that? I would recommend some joint work for some particular instances. There are some tasks that some people just find it very, very easy to do. And funny enough, it's not as if it's very, very difficult, but if two heads just come together, you understand me? You just I did it like this and I got it. You understand what I'm talking about here, right? So many a times that's actually the way science works. And I want to just encourage that that we reach out to others. I mean, we reach out to others concerning wanting clarity. All right. So concerning the availability of the task, I believe that we should be able to have a lifeline for persons. Yeah, but please, I want you to write that question again in the chat and in the WhatsApp chat so that we can, so that we can actually make sense of that. Okay. Hello, Mr. Peter.
All right, sir, that's okay.
Yeah. But please, once you write it in the chat, the program director will actually see it, and you understand. I will be able to praise that some persons. It's just that it's just going to give you a timeline, most likely than not. That will you be able to do this before this time? And if you actually, if it actually fits into, if it is something you can actually do in this timeline. But at the same time, the goal is to go from simple to complex. And in the next 3 weeks, even, if it is something relating to your PhD work, it will even make things very, very easy for you. Do you understand? So it's not just going to be only know-how. Yeah, because there was a particular student that I think she was even a BSc student. She came in, she came for malaria studies. Her work was a PhD work. And the supervisor was actually even saying that it's your work. It has already passed what we are supposed to do. But funny enough, from that work, you understand, the government saw the work and it became a serious grant. Do you get me? So
Yes,
don't underestimate the power of your work. Okay. If you are able to proceed to the second stage, to the third stage, why not? All right. That being said, to bring our talk to an end, I will just share my screen. And I want to thank you everybody for joining the free introductory bioinformatics workshop. Yes, it has been very, very lovely connecting to you and connecting to all. I'm very, very much available on the workshop group. Yes. But once we enter week 2, most likely than not, the phase 1 workshop will be shut down, and most of the assistance that is offered for phase 1 classes, cohorts, will be directed to those in phase 2. So you would get less attentions and co. That being spoken to does not actually mean that we will not help in the way we can. That's one. Secondly, for those that have actually subscribed for the phase 2, or that have actually subscribed, by subscribed I mean that have shown interest, or that have actually paid installments, or executed their first installment or something of that nature, they don't need to pay for this certificate for week 1. All right. Yeah, because it's actually a bunch. It comes together with it. So that is that about that. Phase 2 will actually start as soon as possible. And once we see that everyone is actually doing well, we go forward. Please, we would love you to go through every task that we want. That we have. We have different tracks. Start to look at it and understand it. I believe you can see my screen, right?
yes, sir. That's right. That's correct.
Yes. And finally, before I let us go, peel the trackers. The trackers are actually proofs that you engaged. That one's one. Then also, the international office, they don't just issue certificate. Okay? Proofs. All right. So at that point, I would love to also mention that phase 3 is actually project-based bioinformatics, and there will not only be consultations, there will also be serious work being done. All right, we shall give the support that we can, and make sure that you also become a thinking bioinformatician. Today's session was kind of complex for a lot of minds, but still doable. Yes. So at this point, I would love to say thank you so much, everybody. If you don't have any question, we would close today's session on this note. Do we have any other question? All right. Thank you so much, everybody. Oh, did someone just say something?
Yes, sorry, but I ask the phase 2, what is the price in Naira?
So if you are interested in only phase 2 and not in phase 2 and 3, all right, phase 2, I think that's, is it 45 or 50,000? I think it was sent to the mails, so please check your welcome mail. If you subscribe, you should get a welcome mail. Yeah.
All
If you
right.
subscribe, you should get a welcome mail. Yeah, but I will do that real quick, and let me check that for you. So there was a welcome mail that was sent to everybody, the career development alert. All right. So for the phase 2 in Naira, that's $45, which is 50,000 Naira according, and then it also comes with a completion of certificate upon. I mean, it also includes certificate fee. I mean, so it actually includes certificate fee. So I believe I've been
Sorry,
able to
please. Where did you
question.
guys lost me? I never knew my data. My internet had gone off. I was just busy presentation screen, talking. Apologies for that.
Yes, well, I was able to share my screen, and
Oh, great.
And we spoke on phase 2 and phase 3. We also talked about different tracks, and we answered some questions. Then Mr. Peter here is asking how much is only phase 2, and I just checked now that the $45 that amounts to 50,000 Naira. Then I also mentioned the fact that that there is a certificate included upon completion. So would you love to add one or two things to it?
Okay, thank you very much. May I ask where exactly I was disconnected? So that helps to guide. Maybe there are any specific information I shared and I want to just repeat.
I think you were disconnected already when, okay, you already talked about the tracks and you were trying to explain how the phase 2, phase 3 was going. I think we were entering phase 3 already.
Okay, all right.
Yeah.
Apologies once again, everyone. I really regret that. I mean, networks and let me see, technologies at times fails. Okay, so back to the questions you asked regarding Mr. Peter. So yes, I mean the phase 2 comes with a certificate and it's going to be an immersive session. I was actually speaking to the fact that the phase 2, in the phase 2 of the 4 months program, would be sharing some forms so that people can get to indicate their track of interest, and then these will inform the courses that they would be exposed to in order to prepare them for what is to follow. The project phase. Okay, I wouldn't know if you got that previously. We'll be sharing that form, and also we'll be sharing in that form. We'll be capturing your interested topic, the topic you want to work on. I'm sure many of us here we are I mean, we might have one idea or the other, or something either from projects we've worked on before that we might want to look at, with the lens of bioinformatics this time around, or what have you. Come up with those topics, and at the end of the 3 weeks training section, we'll be refining that topic again together. You would be refining that topic yourselves, and then we'll get to sit on it to commence the mentoring section. Discuss around with those persons who will be proceeding, to the mentoring session, the research phase, guide on how to get relevant data. I mean, we talk around the maybe focused, focus, maybe disease or what have you want to work on. Just like we stated the other time about someone who was trying to use epilepsy. If peradventure we feel, if the goal is to ensure we compare maybe various population sets, and we are interested in comparing African population, we may want to suggest you, can you look away from epilepsy? Would you like to look into other diseases, maybe such as say sickle cell disease or so? I mean, so this could be compared across the various population, or would you want to stick to your epilepsy and then we look at getting another data? I mean, these are all what we come or follow on the research mentoring phase, and ultimately that will commence a session of hands-on task, applying what we have learned in the focus track session, and also getting guidance from from mentors that are available. So that is exactly on how that program will run. These were some of the things I think I shared when I never knew I had gone offline. I think the other things I mentioned was simply to just speak to the various tracks. We have 5 tracks: genomics tracks, transcriptomics, infectious disease, metagenomics, and data science for biomedical data. Those are the tracks we'll be focusing on from Monday. So we'll be dropping these tracks on the page for individuals to indicate and follow through. And ultimately, I think I restated UREKA vision and Omicslogic. I won't be going into that again. And went on to speak further about the Bioinfo server platform. So permit me to also say something about that. Okay, the Bioinfo server platform. I want to think, Dr. If you can still hear me, right? Hello, Dr. If you can still hear me. Hello, am I audible, please?
Yes, sir, we can hear you. You're audible.
Okay, so let me proceed.
Yes, you are.
So, yes, I just want to show us the Bioinfo server because I spoke specifically to it on that. So this is the Bioinfo server platform. Let me state that in the course of this program, yes, participants will have opportunity to utilize the Bioinfo server platform, which is a cloud-based AI intuitive platform. So I want to run a multiple sequence alignment. I can simply click on genomics here on that platform, click on the upload my data set if it's another data set I'm using, or use any of the demo data set that are already added to that platform. Okay, and then run my multiple sequence alignment simply by following the stepwise algorithm tools that are on that platform. If you do not mind, I can quickly go to that platform and show it to us. Okay, so this is available, and I was announcing that thankfully to the international office, Omicslogic international office, despite that, research access to this platform comes at $150 per month, 30 days. Of course, we have been given the opportunity for all participants on this program to get it at $75, meaning 50% slashed off. Now, having said that, we already indicated this is optional, but that might be something some of us would want to explore. But many of these algorithms and pipelines and things that are possible on the Bioinfo server platform will equally be exposed to us in the usual formats. Let me use there's a pipeline called Bowtie 2T. Okay, Bowtie 2. Okay, it's a name of a platform used for sequence alignment. All right, we can equally run Bowtie 2 on our data set using our laptop. depending on the size of your machine core and the rest, or on a cloud-based without necessarily using Bioinfo server. So meaning individual, that's why we stated earlier on it was optional. But nonetheless, I would still like to, of course, mention that this is a very intuitive AI-guided platform where once you indicate, oh, I want to do multiple sequence alignment, the next set of tools available for you will be pointed to you. Okay, I choose both I2. The next set of steps you need to click will be there for you, and a whole lot of that. It makes learning and starting out easier. So that was just other thing I think I mentioned, just for us to know resources that is available that we can leverage on during this 4 months long program. So that will be that. Dr. If I don't know if you have any other thing, or perhaps there's any other question from any of us, we'll be glad to take note of that or to take advantage of this little time to respond to that. I equally did mention that there were 1 or 2 persons who had reached out that they are having challenges with payment from their region. Apparently they are not in Nigeria. Okay, and we are currently looking out on means through which their payments could be gotten, especially since they also wanted to take advantage of the instrumental payment. So we'll see what we can do and work that out with our participants, because our goal is to just see that many of us are able to join, many of us are able to learn and develop and grow and form part of our community. Okay, because the goal is to form a bioinformatics UREKA Omicslogic community. Okay, and then get to collaborate and work together. And I think I also mentioned earlier on, not knowing that nobody was hearing me, we've had several situations where past participants of our program still reach out to us on those WhatsApp group. That's why we will not close those WhatsApp group even at the end of the program. All right, reaching out, asking 1 or 2 questions or resources they might need or help regarding something they need or they are doing, and we still respond, or someone else in that community who is very much vast in that aspect, we respond. So it's a community, it's a scientific and it's a learning community. We are learning together, we are growing together. I think these are a few things I think I should stop at that point. Over to you, Dr. Anyofe.
All right, thank you so much, sir, for that summary. Can you hear me, everybody?
Yes, I can.
Hello.
On my end.
Yes, you're
All right. I am going to call you now, Mr. Peter. I think you still have a question, but I want to also underline the fact that we are actually professionals, or bioinformaticians and so on. For some persons, in fact, it has actually happened severally where we consulted for PhD holders so that we can give clarity to their work and so on. By giving clarity to their work, it means that we help them to understand, design their project, the standard way, and so on. So there's actually a lot of things we can actually do together. So feel free to reach out to us. I believe we are quite friendly people. So feel free to reach out to us. I know that you have I think someone still have a question, right? Do we still have anybody that has a question before we round up on this note?
Yes, sorry. It's still on the question I asked earlier. You told me to share on the platform. So I don't know. Since the program officer is here, I don't know if I can repeat the question or do I
Alright.
just
Yes,
on the
yes,
platform?
yes. Go ahead.
Okay. Yes, sorry. The question is based on some of us who are also engaged in other activities. So it might be difficult for us to follow each of the day-to-day programs, such as the day 1 modules and everything. Like I'm on day 2, though towards the end of day 2. So I'm yet to do day 3, day 4, day 5, and all. So, but since this phase 1 is coming to an end, do I still have a chance of completing those the remaining modules or lessons within I don't know how long it should be accessible?
All right. Yeah. Thank you for that question. It's a good question. So yes, I understand that part, and in fact, I think I also spoke to that, not knowing I was offline at that point in time regarding the timing of this program and training. We've got some feedbacks that some individuals, 2 o'clock they will still be at work and what have you. So we'll take those, feedbacks into considerations and consider them when planning some other times. But some of the times we have had programs before now, we've had 10 a.m., we've had 11 a.m. In fact, I know we have had programs that started for 1 p.m., 2 p.m., even and also 4 and 5 p.m. But 5 p.m., some individuals will still complain, oh, sorry, it's late for us, or sorry, I'm even on the road at that point in time, coming from office, trying to go home. No thanks to some of us who stay in big cities like Lagos, where 4 p.m. you left work and you won't get home even until 8 p.m. So apparently there's no time that will equally be very conducive. And again, there are some persons who are joining 8 hours or 6 hours ahead of this current time. So currently it's 4 p.m. here, 4:08. They are 10:08 p.m. in their own time. And we have some persons who are 6 hours behind us. Apparently they will be during work hour and a whole lot of that. So apologies for that, but these are some of the nuances around timing, for our programs. Nonetheless, we leverage heavily on trying to ensure we share the videos afterwards. Now, back to your question regarding those courses. One of the things that we encourage is please ensure as much as possible you do not let many of those courses or daily tasks to slide by, thinking I will have time to do them, I will have time to do them. I mean, the best would be that as much as possible within each day you try to cover those courses. And I can bet you, in fact, there are courses that has, let me say, 13 lessons, 14 lessons. At times, most of them you can complete within 28 hours. 28 hours is beyond the day, but then it means you can spread your time. There are some 5 hours. That's why they have a whole lot of lessons. So the beauty, or what I will encourage, please, Peter, and to every one of us, is to find a time always. This is more like you. If you had gone and you paid maybe, even if it's 15K or 20,000 naira for a workshop that takes you to maybe a venue, I'm sure for that day or for that week, you are just there to get knowledge that when you return makes you better. So let's look at it that way and try to create time, because it won't always continue like that. I mean, it's just a 5 days training. So to your question, yes, you will still have access to it, but I will encourage between now and Sunday, all right, between now and Sunday, try and complete those courses. I would greatly encourage, try and complete. And I can bet you tomorrow, thankfully, is Saturday. I can assure you that if you sit 3 hours, you will complete 2 hours. You will complete most of those courses, I mean, those lessons, and, be up to speed with where we are all currently are. So that is my encouragement. But now, most of what I said, please do not get me wrong. I said it because of the phase 2. Okay, it's going to be much more immersive, much more demanding. And I mean, you should, I can't imagine you paying 50,000 naira to join that session and then not maximizing. We are not even interested in your money. We're interested in you becoming a bioinformatician like us, that we can work together or can even do a whole lot together. So we are interested in the community, not in the money. So meaning, if you even pay that amount, please ensure you go through, because it's going to be demanding of our time. But I can assure you, you can still get them done. It is very doable. 2 hours every day, you get most of those things done. We've had consultants, medical doctors who will tell you, I'm busy to the teeth. Yet, they still find time to just get those things done, get the knowledge. So I hope that answers your question, Mr. Peter, regarding still having access to, after now. So till Sunday, like I said, I encourage you that on or before Sunday, try and complete those lessons and courses.
It's okay. Thank you very much, sir.
Yeah. Cardmare, please. I think I can see your hand. Yes, hello? Cardmare, do you have a question? The hand is dropped now. Okay, in the absence of any other question, I think we should be calling it a wrap and closing this section so that the video does not get unnecessarily too lengthy. Doctor, if any other thing to add before we call it a day?
I believe that's all. Thank you so much, everybody.
Thank you all for your time. We look forward to receiving our post-training surveys and every other engagement.
The link will be shared, and feel free to ask, please, Mr. Peter, please, this question is actually relevant to a lot of people in the chat. I would love that you still write the question again in the WhatsApp chat and Telegram chat so that we can answer it. All right?
All right, yeah.
Yeah, thank you so much. Have a great evening, everybody.
Thank you all.
Thank you, sir. We are grateful.
You're welcome.